Am I live? Fantastic. Hello, everybody. It's another great Saturday. Really great to be here again. I always like hanging out with Pythonistas, right? By now, we're great Python programmers. We've made giant strides. We've learned a lot, right? We are in the stage where we're learning or we're practicalizing everything we've learned from Python lists to tuples to dictionaries um, to functions down to OOPs to classes, and now we're working on our personal project. Right, that's pretty amazing. That's amazing. I'm trying to think back to the first time you actually just stepped onto the class. Right, it's been um, it's been. I know for me, it's been um, a stepping stone, right? It's been stepping stones, challenges, but now we're here. Pretty amazing stuff. Okay, so today I want to encourage. I want as much people that can come on stage to come on stage, right? So again, you know how we do it. Just put up your email, and you'll be given the link to come on stage. Yeah, I want to see what you've done with your project. I want to see how far you've gone. I want to see what challenges you ran into. I want to see your thought process as to how you are working on the projects, right? Project one and project two. Um, if you finish project one, fantastic. I would like to see it. If you finish project two or you are encountering challenges on probably how to think through the process or how to code the process, it's absolutely fine. We've all been there. So I would like for you to just drop your emails on the comment section or the chat section, and you'll be given the link to come on stage, right? So I'm looking forward to that. Meanwhile, I'd like to see people who are online today. So yeah, if you could just signify by saying hello or um, yeah, today I just want today to be as interactive as possible. I want today to be very interactive. So I'm looking forward to interacting with Jonathan. I'm looking forward to interacting with Blessing. I'm looking forward to interacting with all you guys, right? Everybody, everybody. Yeah. So I'll just give a few seconds, and next few seconds I'll jump into my Python notebook, and we'll just go through, do a quick revision, and see what we can add into everything you've learned, and probably simplify the project you're working on. Try to simplify it. All right, because at the end of the day, the idea is not for you to just pick up a project and not be able to do it. The idea is for you to pick up a project, see it to the end, and then learn how to do your project. So the how to is the role I'll be coming in to assist you with, right? So on that note, okay, we don't have a lot of people online. All right, that's fun. That's fine. Okay, so let's jump into my notebook. I'll just quickly share, and we'll try to break down the project using pseudocode. And I'm sharing in one, two, and fantastic. All right, so I'm sharing. Let me just push this to the right. Okay, so yeah, week one, we covered print statements. For those of you who did not get access to this notebook, you can always still ask, right? You can always still ask. It's still within your reach. So we worked on print statements. And yeah, once you ask, you would get this notebook exactly as it is. And of course, you could practice with it. Um, yeah, so we worked on print statements. We said print statements are a way to output your your results for viewing, right? So you could basically see. Sometimes it helps you see what's happening behind the scene, right? So probably when you want to debug your code, debugging means when you want to find errors or find mistakes or basically find out what's happening in a particular chunk of code. That's what debugging means. Print statements are very fantastic. They would help you see what's happening there. And of course, if you want to output something to the, should we say, to the output box, let's put it that way, because sometimes it's not to the console. If you're working with PyCharm, if you're working with VS Code, if you want to output anything to the console, print statements are your friend. If you want to um, basically see, like I've said before, see what's happening behind the curtains. All right, so then we went to data types. We talked about strings, we talked about integers, we talked about floats. We said strings are basically implemented with quotation marks. So anything you input within quotation marks, be it single quotation mark or double quotation mark, it's the same. The Python interpreter would see it as a string, to interpret it as a string. Then we went ahead to talk about integers, right? We said integers are basically what we see as number values, um, single digit, double digits, triple digits as far as it's numbers, right? It's integers. Then we talked about floats, and we said floats are basically decimal values. Once you have a point something or dot something, it's a float, right? There are other data types. We have booleans, we have hash tables. Um, we have more. We have a lot more. We have queues, stacks, and all, right? But we're just going to focus on strings, integers, list, floats, and then we talked about indexing. We said indexing are a great way for you to, bring out items in a particular position within a string or within a list or within a tuple or data structure, whatever it is, just to bring out what is in a particular position, right? So that's what indexing means. Right, and then we went through this example with using the square brackets and putting the index value. You could call out the particular um, item on that list, that particular item in that position, rather. Hey, great to have you, Olusegun. Shagun, please, I need you on stage. Could you put up your email as quickly as possible so you can be brought on stage? I want to see what you've done. I want to see your challenges. Um, Okay, so moving on, variables. We talked about the concept of variables, how they are containers, buckets. Um, um, Basically, they take in or keep in, store in data types, right? And then you could use them several times to bring out whatever you stored into them. So in this case, we're saying price is 10.99. This is a float value. I'm putting a float value into this price variable, and then 13 into age, Daniel, string of Daniel into name, is false, Boolean figure false into is published, right? So we're printing price, printing age, printing name, printing is published, right? Okay. Shagun, please could you drop your email? I want you to come on stage as soon as possible. Um, yeah, and we also dropped in blue, string blue into this color. Yeah. So let's talk about input statements. Input statements are basically used for taking in value um, into the program, right? So in this case, we're asking what is your name, and we're putting that into the name variable. So whatever you type gets stored into the name variable here. It's as simple as that. Um, So you can see once you print name, whatever you store into this input command or um, this input box, right, to be stored into name, and then you can print it as many times as you need. Then we talked about the fact that once you've giving a variable a particular name and you give it another name later down into your code, um, the name variable changes, right? It changes, it doesn't stay the same, right? So yeah, you can see what we did with this. Rahima, is Rahima online? Um, yeah, Shagun, that's fine. You could come in with your dad's email. Basically, the system you're using to connect with us right now. That's all you need to connect with, right? That's what the email you just need to connect with. So it's fine. You could use whichever email you have access to. I just want you to come on stage and I want to see what you've done, right? I want to see your progress so far. Rahima is not online yet, I think. Rahima, I'm looking forward to seeing you. Um, so yeah, we worked on a few exercises. We worked on printing name, taking in the name variable or taking in a name input, put it into a name variable, and then printing out that name variable. We also talked about um, the same thing. So we're taking, in this case, we're taking name and color, and then we're using a formatted string to print them out. This F here stands for formatted. Right, so that's that. And then we went to, let's quickly pull this down. Good. And so we went to week two. In week two, we talked about type conversion. We talked about how you can convert int to float to Boolean figure, um, and how you can check the type of a particular data type. Um, let's see what we have here. Yes. So we worked with a simple example of taking in the birth year. In this case, the birth year comes in as a string, right? Because input takes in information as a string. And then we checked the type here. Again, I said we could use print to or type print to bring out whatever is happening at the backstage to our front view. So that's what we have here. It's telling us that the type of birth year or the type of information in birth year, if when we put it out to the console, it's a string. That's what this means here, right? So and we're saying 2021 minus. Now, if this were just 1960 that we imputed here, it will give us an error. Why? Because you cannot subtract a string from an integer. So we have to convert this integer here. That's this string here to an integer. That's why we're using um, this int word here, and then we're passing or int method here, and then we're passing the string variable into int. So this converts it to an integer, and then we print it out. So that means integer minus integer will give us an integer, and then we print it out, right? So that was pretty simple. Um, then we talked about math operations. Um, we talked about addition, subtraction, division, multiplication, exponentiation. Now, one of the beautiful things about Python is it's pretty close to what we're used to in terms of math and English, right? It's almost like writing and reading English, and it's almost like working with simple math, right? That's one of the beautiful things about it. The language itself is easy, which makes it easy, which makes it a little bit more easy to put your ideas into code, right? So the difficult part of Python or coding when you're coding with Python is that you just need to, it's the conceptualization, the arrangement of how you think your code should flow. That's where the issue is. It's not really in the syntax. That's how you write it. It's not really in the syntax, right? So the syntax is pretty easy. That's why we have the same way we have addition in English language or math. It's the same way we have addition here. We have subtraction, divide, multiplication, and then exponentiation. So that's basically it. And then we did a little example. 10 plus 10 is 20. You pass 20 into the added number variable, and then you print it out, and we have 20 here. All right. So the same thing for subtracted number. 20 minus 15, subtracted number. 50 divided by 2, divided number 25. 5 times 5, 25, right? And then 2 raised to power 6 is 64. So that's basically, this is just an example to show the math. There are many others actually, but these are pretty basic. Um, this is basically a very simple. We're trying to keep things very simple and easy to grasp, right? So the other ones are beyond the scope of this course. As you go further down your Python path, they would be easier for you to tackle or grapple with. All right, so if you print them out, these are the figures, are the um, answers, right? And then we talked about comparison. Comparison. We talked about basically these return true or false. They return either true or false, right? So 5 is greater than 2. That's true, right? So true will be stored into Boolean 1. 20 is less than 5. That's false. So false will be stored into Boolean 2. 7 is equal to 4, meaning this is not true, so it's false. False will be stored into Boolean 3. I'm just going through um, the symbols. 5 is not equal to 3. That's very true. So this will be stored. Boolean 4 will be true. 3 is greater than or equal to 5. 3 is not greater than 5. Neither is 3 equal to 5. So that's why this would be false. False will be stored into Boolean 5. 3 is less than or equal to 5. 3 is yes. 3 is less than 5, but 3 is not equal to 5. But because one of the conditions is satisfied, which is 3 is less than 5, this would be true, right? And then if we print out all the Boolean figures stubbed into these variables here, we see their values. All right. And so we went on to talk about if then statement, or let's turn it to if else. All right. So okay, so we talked about, I believe this was a little difficult to work with. I know, nice to have you here. I know, can you drop your email if you've been part of the class? I want to see what you've done so far. I want to see how far you have come in terms of coding, and I want to see what you've done on your project, right? So, okay, so it's true. In this case, we're passing in um, a Boolean figure true into is hot, right? And another Boolean figure true into is cold. These variables here. So we're saying if true, since true is here inside or hot. So if true, print it's a hot day, drink plenty of water. Else, if it's not else, sorry, if it's cold, print it's a cold day, wear warm clothes. Let me take it again. If is hot is set to true, which it is, print it's a hot day, and then print drink plenty of water. Else, if is cold is set to true, print it's a cold day, print wear warm clothes. Else, if it's neither of all the above conditions, print it's a lovely day. And then when you're done with everything, inside this if, else, if, and else, print enjoy your day. All right, so because this is true, this is what has been set to true. That means this will be printed. This is the only thing that will be printed from this whole block of code. If this was set to false, that means this is false, don't do it. This is set to true, do it. Then it will print everything here, right? And if none of them is set, none of the above here is set to true, print this. That's what it basically means. And then once you're done with everything above, print this. I hope that makes sense. So that's what we talked about. It's basically simple, very simple actually. We went a step further, and then we talked about, we put the same if else statement into practice, but this time around we introduced comparison, right? So we said temperature, we set temperature as 30. We passed in the 30 integer into temperature. So we're saying if temperature, whatever is stored in temperature, if it is not, that's what this means, not equal to 30, print it's a hot day. Else, print it's not a hot day. In this case, we don't have an else if. We could introduce an else if you want to practice with it, but we don't really have an else if here, so we could just work with this. But just saying basically, if temperature is set to anything that is not 30, print this. Else, print, that means if temperature is set to 30, that's what this else means. Print it's a hot day. Of course, this is not very accurate, but just for explanation's sake. So yeah, temperature is set to 30. So 30 is equal to 30. But in this case, they are saying if temperature is not equal to 30. But 30 here is equal to 30, but temperature is equal to 30. So this would not run. It will skip that, and then it will print the else block, whatever is in the else block. Right? Okay, so we tried to build a simple program that would tell the user if his name, or tell the user to input his name and then make sure that the name is within 3 to 50 characters, right? That's what this right here is, this block of code is, right? So saying taking a name input, once the person imputes his name, if he imputes a name, len name means length of name, the length of the number of letters in the name. If it's less than 3, print name must be at least 3 characters long. Could just put, right? Else if len name is above 50, that means if the length of the name is above 50, print name cannot exceed 50 characters long. Else print name looks good. Let's walk through this slowly. If the length of the name, that means, for example, if you have CJ or CJ, yeah. This is 1, 2. There are only 2 letters here. Because it's less than 3, this command would play out, or this will run and say name must be at least 3 letters or 3 characters long, right? But if it's above 3, say CJ, or let's say Pearl. Pearl is 5 letters long. So this would not run. This first one will not run. Then the second one says else if name is greater than 50, print this. Well, 5 is less than 50, so this would not run too. Every other thing apart from this, to print name looks good. So because our name is not less than 3, the first if statement will not run. Our name is not above 50, the second if statement will not run. Then that means the last if else statement would run, right? So that's what this is. So we can just wipe this out. Okay. So we went through this assignment. Okay, yeah, this was us just doing the assignment above. So we talked about week 3. We talked about data structures. We talked about lists, tuples, dictionaries, arrays. There are many more, right? Like I mentioned, there are queues, stacks, hash tables, graphs, but they are beyond the scope of this course, right? So I said lists are mutable data structures, meaning that they could be manipulated. They could be, you could change the position of the items in the list. You could split a list. You could call out an item using the index, just like we did here. We're saying give us the last item in the name list variable here. And of course, the last item is John, which is why we have John here. And then we did the same thing for tuples. We're saying give us the second to the last item, which is this will be -1, this will be -2, and then James is printed here. And then we talked about dictionaries being name value pairs, key value pairs rather. It helps us store two values together, right? Two values that have some form of relationship together. So in this case, we're storing names as keys. These names on the left hand side, they are keys, and then the values attached to those keys are on the right hand side. So we're saying Daniel, Sarah, James, John, and these are the values attached to them. So maybe, for example, scores in class for a particular topic or a particular subject or a particular course, right? So we want to store that um, into the memory of our program. What you just need to do is put that into a dictionary, and then everything will be stored. And so, if you want to get all the keys like we have here, just use the dictionary, name of the dictionary, and then keys, and of course add the open and close parentheses, and the same thing too for the values. If you want to print them one after the other, you would have to loop through them. We've talked about for loops. Okay, we haven't talked about for loops, but this is just a great way to print out each item one by one. Um, and so we talked about name dict John here. This is basically to give us what value was attached to John, right? So in this case, saying is 85. Let's just quickly confirm. Yes, John 85, right? It's as simple as that. And then we talked about array. We talked about arrays. We said arrays are like lists, but they are faster than lists, basically. And basically, they're for numbers most times. That's why it's called NumPy. That means number calculations or arithmetics in Python. That's why it's called NumPy. And so we're using MP. We're saying import. We could actually just say import NumPy, and this would be NumPy. But we're saying import NumPy as MP. So anytime we type in MP in our code, it knows that we're referring to NumPy, right? So we're saying numpy.array 1 2. We're putting in double two integers into this numpy array. Excuse me. And then we're storing it into the MP array variable. The same thing here too. And then if you want to check the shape, this is a 2 by 1. This is a 2 by 2 array. And so we went further to talk about loops. We talked about while loops and we talked about for loops. We said while loop is a loop that will continue to run until a certain parameter is fulfilled or certain condition is fulfilled. Right? We said, let me see. Okay. I'll come back to your question, Laomi. When do you use else if? I'll come back to your question. Jane, can you come on stage? Can you drop your email so you can be brought on up stage? I want to see what you've done. You've been part of the class all through. Um, so yeah. So in this case, in the while loop case, we're starting with one. We're saying I is equal to one, while one is less than or equal to five. Print I. Now, of course, if I just stopped the code here, the code will keep on running infinitely because one is always less than five. So it'll keep running to keep printing I, keep printing I. But then we now said in the next line, we said after you print I, after you print the first I, increase I by one, add one to I. That's what this means here. Add one to I. So in next I becomes 2. It goes back. I is 2. Is 2 less than 5? It checks. Is 2 less than 5? 2 is less than 5. It prints 2, which is why we have 2 here. Then it adds 2 to 1, making it 3. Turns I to 3. Checks. Is 3 less than 5? It keeps doing that until it gets to 5. So once it gets to 5, 5 is equal to 5. Once it gets to, if it comes down here as 5 plus 1, that's 6. um it checks, is 6 less than 5? No. Is 6 equal to 5? No. So the while loop ends and then it prints done. Same thing too for loops. Loop is a little different, but it's an iterative process. You're going through the items in a list or in a tuple or in a data structure. That's what for loops do. So we put in 4 items into this name variable, and then we said for item in name, which is 1, 2, 3, 4 print name. So if when the first time it puts Daniel into item and printed item, which is Daniel. When the second time put Sarah into item and then print Sarah. Next one, you put James into item and printed James. The same thing for John, right? And that's how for loops work. We talked about, then we went a little further to print the item in a triangle, right? So for num in triangle, 1, print x times 1. So in this case, the first time x is 1, or num is 1. So 1 times x times 1, print, that's 1x here. The next one, num is 3. X times 3, that's why we have 3x's here. 5, 5x is here, 7, 7x is here, and then 10. All right, and so we had excuse me. Okay. Okay, so We did two exercises: create a list of 30 numbers, use a for loop to print out the first 20 numbers, right? This is a little different, so I'll just quickly do this. It's pretty easy. Um, so let's create a list. Um, how do we go through this? Okay, so first thing first, we need to create a list. Now, how do we want the list to look like? Do we want the list to be a random, a set of random numbers, or do we want it to be a list of 1 to 30 numbers? That's from 1, 2, 3, 4, 5 down to 30, right? What do we want? You know what? We can just do the two, right? So we create a for loop, we create a list first, 30 numbers, um, and we loop through them. We loop through 20 of them. Okay, we can loop through everything and then loop through 20 of them just so we see. Um, this involves the mixture of two concepts that we've talked about before. So let's try it. So let's create a list. Create a list by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the hard way. Right? Let's call it non. Let's call it non list. Right? Okay. And let's loop through. So for num in num list print num. Right? This is one way to do it. Jane, can you drop your email? I want you to come on stage. Okay, so 1 down to 30, right? Now we could actually make this was long coding, right? We could actually make this easier. Um, let's do, let's use range. So um, we could just do for num in range. Let's try 30. Print num. If I'm correct. Yeah. So we got the same thing, only that this started from 1, this started from 0 down to 29. Right. Remember, if you use, it doesn't print the last statement. If you use a range, prints. We could do this from 1, if I remember correctly, to, you could always check Google. Okay, so invalid syntax. Oh, okay. So let's do this. Yeah. Okay, so from 1 to 30. So we have the same result with fewer codes, right? If we wanted to skip through, we could put a 2. That means after 1, go to the skip 2 figures and bring the next one. So let's try this. Yeah, so you can see 1, 3, 5, 7, blah, 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 down to 30. Um, what other thing could we do with this? Okay, so how do we print out just a group out of 1 to 30? I want to pick this one. Let's work with this. So remember, if you want to get the items of a list, a chunk of the items of a list, not the entire list, you use something like this. I know you guys remember. So this means everything from the beginning to 20. Let's try this and see. See it? So this is exactly what you're supposed to do for this first part. For this other part, it's pretty easy. You just need to multiply. Item is num list. You're supposed to multiply the first item, which is 0, and the last item, which is -1. Remember? And then pass that into, what do we call it? Let's just call it and C. Okay, then if we print out and after that is done, see what ants will give us. 30. So that means 30 times 1. 30 times 1. All right, so Enioluwa Ogunyemi, I need you guys to drop your email so you can come on stage. I need you guys to come on stage. All right, so we talked about functions in classes. We said you use the def keyword to define a function. This is a function that doesn't take any parameter. All you have to do is just type in say hi, and it will print just like this. It will print everything inside the function in this case. Then we talked about a function that takes in a parameter. In this case, this function takes in the parameter name. And then once it takes in the name, it brings it inside the function and does what the coding in the function is. In this case, the coding is print name. So it prints whatever you passed into name here. It's as simple as that. And then we passed in Daniel and it printed Daniel twice because we have print name, print name. Okay, then the next one is greeting. This one takes in two parameters, takes in name and then takes in age, right? So once you do that, you say hello, whatever was passed into name will be printed out here. I know you are, whatever was passed into age will be printed out here. And then it prints that out. So we tested it out using Daniel and 99, Sharon and 50, right? And then he printed it out. We didn't have to write this several times. You only had to call the function here and pass in the name and the age, and then the function did the remaining. That's one of the beautiful things about functions. They help us. We just have to call a particular function, and we can do several things with that function over and over and over again. We don't have to retype it. Okay, so this looks familiar. This is a dictionary, if you guys remember correctly. These are keys. These are dictionary keys. These are the values of the keys. That's why it's called key value pair. And then we said for name and age in students.item. That means go through the items of this student dictionary. In this case, we have name and age. So it takes that as one and then pass that into the greeting function, we have here, just like we have here. And then we have, in this case, we have Sharon and 50. The next time it goes again, for the next item, we have James and 40, just like we went through the lists. It's the same thing. Then we have Laomi and 30. That's why you have Laomi, 30 years old. Jonathan, 60 years old, right? Fantastic. All right, so then we talked about classes. Classes are very simple, even though some people might find it difficult to understand. It's actually very simple. So we said one of the beautiful things about classes is it puts several functions together. That's what classes are. They put several functions together. Um, so if you check, all these functions are basically about meeting a new person. Let's just put it that way, right? You're meeting a new person. And so we call the class meeting. And we said the class itself is different from function. You can see that we initialized, or we're creating the class using the class keyword. If it were functions, we would have to impute parameters here, right? And here, right? But for classes, it's a little bit different. You don't input any parameter here. You don't create any space for inputting an argument. You just create the class, give it a name. Then if you want to put in parameters, you would have to use, first of all, the keyword for a function, but this function will be called an init. That's the standard. It has to be called an init. And then you have to use self. Self here is because sometimes you want what is defined in this first function to be used in other functions. Self, self. So this self is a connector, is what connects all the other functions together, right? That's why you can define something in one function and then another function can take from that function because you use self. If you don't use self, you won't get that result. So we're saying at the point where you're um, instantiating this meeting, you have to pass in a first name rather, a last name, and then an age, right? So so once you pass that in, this is what you have here. Last name is what you have here. Age is what you have here, right? So self dot we're now doing this so that we can use this things that are passed in here in other functions. So we're saying self dot first name. We're adding self to it so that it can be used by other um, functions. Self dot last name and then self dot age. Once we've done that here, we can now call these things in another function. So in this function, we say print first name self, right? Connecting this to the other function. And then we say print self dot first name. So it prints whatever is in self dot first name. In this case, first name is in self dot first name. So it will print what the person imputed here. I hope that makes sense. Then the same thing too for print last name self, then self dot last name, print self dot last name. Then greetings self, hello self dot first name, self dot last name. I know you are self dot age. Yes, bold. Nice to meet you. And so we tested it out. At the point where we're initializing this meeting here, we have to pass in three parameters: first name, last name, and age. First name, last name, and age. I hope that makes sense. And then the same thing too for Jennifer. And then we tried to once we're done with that, we did meeting dot first name, right? Then meeting dot print last name, right? This meeting here is the first name, this is the last name, and then I'm sure if we did meeting dot age, if we added meeting dot age here, right? If we do this, it'll be meeting dot print age, and then whatever was stored into age or self dot age we printed out, and then we did it for another set meeting two, which is here, which is what we defined here. We could as well just do this, and then everything there for meeting one, and everything here is for meeting two. And so we talked about pretty much the same thing. Now, in this case, we're defining a class, but we're not using an init function. We're just doing a very simple class, which is class called first car, and then dot model. We're saying whenever the person imputes first car dot model, give us Honda. First car dot color, give us blue, which is what we have here, right? We're calling this class car. So car.model, car.color gives us Honda and blue. The same thing here too. And then we see how we can change whatever was passed into the class variable, right? You can change it by this, giving it another, just like we can change what is in a variable, we're giving it another value. In this case, in the next case, second car, we have an init function, right? It's not taking any parameter. Second car is not taking any. As we are putting something here, something here, something here, that means it's taking in these parameters. But in this case, it's not taking any parameter. We're defining the parameters inside the class function. So regardless of whoever calls it, self.price will always be 40,000. Self.color will always be red. Self.model will always be Tesla, regardless of whoever calls it, right? So that's why this you can see self car 3, which we said is equal to second car dot price is equal to 40. In this case, the third one, this one is taking in parameters, price, color, model. We want so that at the point where you're defining the class, you're able to change or give it whatever price you want to give it whatever color you want to give it whatever model or brand you want to give it, right? That's why this is there. But when it wasn't there, we'd have to define it inside the function, init function, and then it doesn't matter whoever calls it, it will give you the same result. But in this case, if you're calling it and you give it a different price, it will pass a different price into it. And then this is just a simple way of implementing another. This is another type of class. This class is called operations. We define a new kind of class. We said, okay, well, at the point where we're defining a new kind of class, we're passing A and B. And then we say self.a is equal to A, self.b is equal to B. So anytime we want to get the value that was put into A, we just type self.a, right? So when we want to add, we put operations.add, and then self.a will be added to self.b, and it will be returned. The same thing for subtract, multiply, and divide. We talked about this last week. And you have a project to work on. I'll just skip on down, and then you have a project to work on, right? I won't touch this project, not yet. By next week, we would actually um, um, break down the project and probably work on it, most likely work on it together. But I hope that it's something you have pushed, you're trying to solve by yourself. You're trying to push through by yourself, because that's how you pretty much learn. And don't forget, Google is your friend. If you have any issues that you're trying to solve, you could just tick the error. For example, we have an error on this page. I deliberately left it there. So all you have to do, for example, is we have a name error. You could just copy out the error like this, right? Copy it out, open a new page and paste it in. and then you would see that many other people have had similar errors, right? So if you click in, it'll tell you how to fix the error. And then this is a question somebody has asked before. These are answers that people have given. Most times when you see this green pass mark, that means somebody has given the correct answer, right? The more people vote for it, you would see the number. That in this case, only three people have voted for this answer. So you can still check it, see how it relates to your own code, and see what you can make, what change you can make to it, right? So that's how you go through. You um, resolve some issues that might come up when you're coding. That's one way. Another way is to just basically click on search Stack Overflow. You can see it took me to the same thing here on Google, right? So on that note, come to the end of the class. Um, Really nice to have you guys here again. If you have any issues again, you could always send a message across. I implore you guys, please send a message across so that you don't have the issues you have can be fixed and we can work on it with you, right? So, on that note, Jane, Olusegun, Aino, Laomi, um, in your Lua, nice to have you guys in the class today. I'm looking forward to seeing what you guys can do with what you've learned so far. And on that note, it's a bye bye from me. Great. All right, guys. So I'll just move over to the next class, and then I'm sure, yeah, you can send your emails to hello@coderina.org. If you have any questions, any issues, you can just send them a message or send us a message, and then we'll get back to you. And on that note, I'm handing over to my co-facilitators.